Let's have this. Find the common ratio of a sub 1 if a sub 1 is equal to 64 and a sub 6 is 1 over 16.
Okay, so the problem is a sub 1, 64, and the sixth term given is 1 over 16. Find the common ratio. Well, with this problem, we're going to still use the given formula of geometric sequence, which is a sub 1 r raised to n minus 1. Now let's identify first the given. Well, a sub 1 is 64, and then your a sub n here is 1 over 16, and that happens to be the given sixth term, which means n is 6. And then we're going to look for r. So let's substitute this now here. This is 64. 1 over 16 is equal to the first term, which is 64, times r raised to 6 minus 1. So with this, we'll have 1 over 16 equals 64 raised to, r raised to the 5th power. So let's remove this by dividing both aside, or I can have instead the reciprocal of this, which is 1 over 64. Okay, so cancel this, leaving only r to the 5th power. And then 1 times 64 times 16 is equal to 1024. Now that we have only r and then the 1024, let's remove this by extracting the roots, the 5th root, since that is raised to the 5th power. And then cancel this. R is equal now to the 5th root of 1 over 1024 is equal to 4. So that is now the common ratio, 1/4.
So this, another problem. Find the common ratio if a sub 14 is 768 and the 5th term is 3/2. The given problem is the 14th term is 768, then the 5th term is 3/2, and then find the common ratio. Now with this problem, we cannot right away use the general term of geometric sequence, which is this one. It is because we don't have first term here. Okay, but the thing is, I'm going to solve this problem by making an adjustment, by making a sub 5 as the first term for me to get the first term, and then the a sub 14 will be also adjusted. Since I am making a sub 5 as the first term, which means I am going to convert, make a sub 14 as a sub 10. I repeat, I did make an adjustment by changing a sub 5 to a sub 1 for me to use this formula, for me to get r. Okay? So, since I made a sub 5 as the first term, I'm going to adjust also the 14th term as a sub 10. Because, obviously, the adjustment here is 4. From 5, it becomes 1. And then from 14 also, it will be 10. The adjustment here is 4. So with this, now that I have first term, assuming that a sub 1 is 3/2, and then a sub 10 is now 768, I am going to make the n as 10, not 14. I did use the adjusted one. A sub 1, 3 halves, and then A sub 10, 768. Again, you will not use class 14 here in 768 because I did use the adjusted, not the given sequence. So, by making this, you have now first term which is 3 halves. So we can now use this formula. So this will be 768 equals 3 halves times r raised to 10 minus 1. So let's have this 768 is equal to 3 halves r raised to the ninth power. So for me to remove 3 halves, I should multiply both sides by its reciprocal, which is 2/3. So cancel this now, leaving only r to the ninth power, and 768 times 2/3 is equal to 512. Now that we only have r to the ninth power and 512, we can extract the roots now of this, both side by ninth root, because the exponent is 9. And the ninth root of 512 is equal to 2. So that is now the common ratio. Which means, class, if you don't have first term in the given, you can find ways by making adjustment provided that the other given term should be also adjusted. Like this one, the a sub 5 becomes a sub 1, the a sub 14 becomes a sub 10, and that will be your given that will be used or utilized in the given formula. Let's have the third part of this discussion, which is geometric series. So this time we're talking about the sum of geometric sequence. Now, we only have one formula here in finding the geometric series, and that is S sub n is equal to a sub 1 times the quantity of 1 minus r raised to n power, close parenthesis, all over 1 minus r, or wherein it's the same. A sub 1 is the first term, r is the common ratio, and then the n here is the term that we are looking. Now, noted that r should not be equal to 1. First problem. Find the sum of the first 10 terms of the sequence 5 plus 10 plus 20 plus ellipses. The given sequence is 5 plus 10 plus 20 plus dot dot dot. Find the sum of the first 10 terms. So with this, let's first find all the given information. A sub 1, obviously that's 5. R can also be identified by dividing this with 5, and that is 2. Same goes with 20 divided by 10, it's 2. So R obviously is 2. Since you're looking for S sub 10, your N here is 10, and then we will find the sum of the first 10 terms. So the formula is S sub n is equal to a sub 1 times 1 minus r to the nth power all over 1 minus r. With this, let's substitute all the given in the given formula. So we all know a sub 1 is 5 times 1 minus r, which is 2, and then n is 10th power, all over 1 minus 2. R is 2. So with this, 5 times 1 minus 2 to the 10th power is 1024, all over negative 1. 1 minus 2 is negative 1. So since we can divide 5 by negative 1, so we divide it now by negative, it will be negative 5 Then 1 minus 1024, it is negative 1023. Then 5 times 1023, I mean negative 5 times negative 1023 should be positive. And 5 times 1023 is 5115. Which means if I'm going to continue this up to 10th term, the sum of these numbers of this series is 5115. Second, find the sum of the first 6 terms of the geometry sequence 2, negative 8, 32, negative 128. Find the sum of 2, negative 8, 32, negative 128. Find S sub 6, or the sum of the first 6 terms. So A sub 1 here is 2. Your R here is obviously negative 8 divided by 2 is negative 4. Same goes with negative 8. And then your N here is 6 since you're looking for the sum of the first 6 terms. So applying the formula, S sub n is equal to A sub 1, 1 minus R to the nth power, all over 1 minus R. Let's substitute this now here. The first term is 2 times 1 minus, let's make it bracket, 1 minus negative 4 raised to the nth power, which is 6 in this case, all over 1 minus parenthesis negative 4. So this will be 2 times, well, negative 4 to the 6th power will be positive since the exponent is even. So this will be 1 minus 4096 all over 5. So since I cannot divide this 2 by 5, I'm going to leave it as is. So we will have 2 times negative 4095 because 1 minus 4096 is negative 4095 all over 5. And that will be now 4095 times 2 is negative 8190 divided by 5 is equal now to negative 1638 or 1638. So that's the sum of the first 6 terms of this sequence. To summarize these discussions about geometric sequence and series, if you are finding specific term of geometric sequence, then you have to use the general term of geometric sequence, which is A sub n is equal to A sub 1 times r raised to n minus 1. We're going to find the A sub n. Now, if you're looking for the order of the term, then similar the formula, but this time you're going to identify the n minus 1 or simply just the n. But the thing is, you have to apply here the exponential property, which I have gave in the previous discussion. Now, if you're finding the geometric mean, you're going to use still the general term, but you should identify this time the r, or the common ratio. Now, if you're looking for sum of geometric sequence, then you have to use the geometric series formula, which is A sub 1 times 1 minus r raised to the nth power all over 1 minus r.